Good evening, friends. It's a pleasure to have you all over for the webinar on how technology advances and data management can improve efficiency. We are glad to have with us Baldwin and Mr. John Cusack and Rajaram from Baldwin will be
I think we're losing you a little bit.
Yeah, I lost Mr. Jaydeep's last sentences.
Can you hear me? Hello?
Yes, I hear you a little bit. It's a little bit
Yeah,
low.
you can repeat because there was some disturbance with the network.
Okay. Good evening, friends. Welcome to the webinar on how technology advances and data management can improve efficiencies. This is organized by LMAI and Baldwin. Now I would request Mr. Anurag Mohan to introduce John Cusack from Baldwin who will be taking this presentation. Anurag, please introduce Mr. John.
Yeah, thank you, Mr. Singh. So good afternoon, everyone. I am Anurag Mohan from Interact X Labels, representing as Honorary Joint Secretary of LMAI. And I have pleasure in welcoming you all for your participation in LMAI's third online session of Knowledge Accelerating Growth series. So I'd like to provide a brief profile about the company for today's session, Baldwin. So John Cusack is a business development specialist for Baldwin Vision Systems, a leading supplier of inspection and color management technologies for the printing industry. John has over 20 years of experience managing color inspection and web viewing products for Baldwin and works very closely with end users, OEMs, and brand owners to help bring to market products that directly address the needs of today's packaging industry. So over to John Cusack, Baldwin.
Hey, thank you. Yeah. Thank you all for coming. Looking forward to talking through the presentation today and the topic. I believe I have about 35 minutes to kind of get through the presentation, and then we'll try to keep some time at the end for questions and answers. So I'll basically just get straight into the presentation. So today I'm going to do a very brief introduction, again, a little bit about Baldwin and really the products that kind of fit for our conversation today. And then the two major areas that we want to talk about, which are around technological advancements, things that are changing in the industry that are going to help improve your revenues, improve efficiencies, basically convert your bottom line. And then there's also the data management aspects that goes with that as well. Okay. And then finally, we'll conclude with, putting all those pieces together to say, exactly how that has helped improve your revenue and improve your bottom line. All right. So why are we all here today? So we're here today because we want to hold on to our hard-earned cash, right? We want to try to preserve it or generate as much revenue as possible, but then also improve the efficiency of our business to ensure that we convert and translate as much of that revenue into our bottom line as we possibly can. So areas that we're going to focus on today with the inspection technology that I'm going to talk through are areas where you probably are seeing problems, like in customer returns or customer retention, right? So what happens is we may not have a very good control over the quality or understand exactly where all the defects are in our printing process. And maybe some of those defects are getting into your customers and they're seeing these issues and they're, penalizing you or asking you to reprint product, or even potentially, going to different printers for taking their business elsewhere, right? Quality is an issue as well, right? So do you have a good quality process in place? How do you, what systems and solutions do you use to ensure that you can generate perfect print quality? Then there's efficiency. That was kind of one of the major topics as well for today, is the idea that, what are your people doing to help ensure that you can deliver this high quality to your customers, right? Are you spending a lot of time and energy trying to find waste or trying to understand where the issues are in your business? So again, ultimately, we're going to talk about how data and information can help you become more efficient as a business. And that's the data piece, right? So, today you may have processes that allow you to track material or information through your business, but are you getting enough data, right? And to be able to then translate that data into information to help you make good business decisions, okay? And that's really the most important part, I think, of what we'll talk about today, is not just having data, but efficiently translating that data into valuable information to help you make good decisions as a business, all right? So again, just a very brief outline of Baldwin. Basically, Baldwin, from an inspection point of view, is a coming together of 4 inspection companies. So Verification Systems Limited, PC Industries, Quad Tech, and Vigitech. So between those 4 businesses, we've over 35 years of experience in label print specifically, and over 70 years of combined experience in general print and material inspection capabilities. And one of the things that I'll talk through as I go through the advances in technology is one of the benefits of having pulled these companies together is that you have different concepts, ideas, things like algorithms, IP, ways of trying to inspect materials that we're now combining together into a single platform that isn't just doing simple inspection, but it's generating a lot of high value data. So data that says, not just you have 1,000 defects in a job, but where are the defects? What type of defect are they? Are they a color defect? Are they a variable data defect? How significant are they, so that you can make the right decisions about how to manage those defects? So I'm going to start with something very basic, and then I'm going to build up to the more complex things, because I'm sure we've got a range of people on the call today. But in the Indian market, it's very common for people printing labels to be using web viewing technology for inspection or for quality verification. So that can be a web viewer that's just doing simple manual viewing, and you have an operator looking at the labels and hopefully finding some issues and being able to address them. Some of these web viewing systems have sampling inspection in them, so you're getting some automated inspection. But again, because it's a web viewer and it's taking a picture every couple of seconds on a very small area, you're generally inspecting less than 1% of your production. So you don't have really any visibility. So really, to get good data, the foundation is 100% inspection. All right, so there's a lot of 100% inspection providers out there, and they have camera systems that can look at the entire web, look at every label, at the entire job, and look for the defects. And then you have to say to yourself, okay, how do I take a step up from there? So where's the technological advancement? Because inspection has been around now for quite a long time. So the advancements really come in the algorithms and the software features that are within a given inspection system. So I'm going to just go through a list here. I'm not going to spend a lot of time on each one of them, but again, just to give you a flavor of the type of intelligence that we have in our Guardian PQV product. Okay, so again, it's all about having high quality data, not just information, but being able to have very high quality information to help you make good decisions. So I'll talk a little bit about object-based inspection in a second, but it's one of the most powerful parts of the product. Then we have a thing called dynamic learning. So if you can imagine you're running a job and for some reason you've got some small issue that is in the setup. So maybe you have a damaged plate, or there's something in the setup that you cannot fix immediately, and it's something you're willing to live with. The PQV is able to learn a specific defect and ignore it. All right, so rather than it being a nuisance and continuously being detected, if you make a decision at that time that you're happy to run production with that defect in the workflow, the system can ignore it. So you don't generate lots and lots of defect alarms, and you don't hide other defects that you're concerned about, because that's one of the big limitations of some inspection systems, is they're too aggressive. They find too many issues, and you can't identify the key problems that you can actually fix. And that's where the dynamic learning comes in. And there's a few obvious things like barcode verification. Again, the ability to be able to read each code that's on each label and verify that it actually can be read properly, it's being printed correctly. And proofing technology. So again, the PQV has the ability to do an embedded proofing functionality where you have software within the product that can use a PDF reference file at job start and check that the job is set correctly. And again, that's a critical value added function, because a standalone inspection system, if you put the wrong job on the press, it doesn't know it's the wrong job. As long as the image stays the same, it won't see an issue. So having the proofing step is an important step forward in that you can verify you actually have the right job on the press, and also that the job is truly clean and represents the reference image file that came from the brand owner. Automated setup is another thing that's kind of important. So again, the PQV can use a standalone automated job setup functionality that's based on a PDF artwork file. So it doesn't need a complex software workflow system, let's say like an ESCO system. If you have a PDF one-up image from your customer that says this is what the product looks like, we can use that basic PDF to set up the system offline before the job begins. So you save a lot of time on the press, and you also ensure that the product is set correctly. All right. Then again, from an intelligence point of view, the PQV can do variable data verification. So we're seeing that this is becoming a much more common requirement in labels, in particular, the need to have serialization or some variable content that allows you to have traceability, for example. So the PQV supports the ability to check all of those variable codes in real time and compare them against a database of files that you expect in the workflow. And it can generate a report of all the codes that weren't printed correctly so that you could reprint at a later point. And it also obviously provides an alarm in real time when those issues occur. Live telemetry, I'll talk about a little bit later. This is kind of how you turn data into useful information, right? So we'll be able to show you where we can show you information like how much of a job has been printed, how much more print has to happen, what time will the job finish, to try to help you, schedule next jobs, know when to get the next job on press. And then the defect tracking workflow, I'm going to get into in more detail as well. And that's really the critical part of the inspection workflow and data is, now that you've detected defects, what do you do with the information? How do you actually find the defects, take them out of your workflow, and make good business decisions about how much waste you're willing to accept? Because at the end of the day, you have a margin target you're trying to achieve. And the idea of providing, defect-free product to your end customers probably is not a sustainable model. So you usually have to make trade-off decisions as a printer, as a business, to say, okay, I have 200 defects in a job, but because of the value of the material or the margin that is on the job, you have to ship, let's say, 98% of the material, and therefore you need to make a decision how much of the waste can you take out and how much waste will remain. And it's about risk mitigation and running your business. All right. So I'm just going back to object-based inspection for a second. And this is, again, there's a lot of software features in the product, but I just want to take one example of one feature just to give you a sense of how powerful it can be. So again, just a representation of maybe a typical label with a lot of content on it. So there's a lot of language there. There's some codes in there and some basic color areas as well. So what the object-based inspection allows us to do is generate a much tighter tolerance, generate fewer false detections, and ultimately provide an enhanced inspection. And how it works is a very simple thing. So when it trains on the label, the system, and I'll bring up a zoomed in area. So if we look at essentially just this area under the dietary supplement text, and I have it blown up here on the right-hand side, but basically, that text is made up of a few hundred individual characters. And what the PQV does is it actually can identify every individual character that's in that text, and it can inspect each one individually, rather than treating it as just one area of black color against a white background, which is a kind of a simplistic approach. The PQV is able to track every letter individually. And the benefit of that is when you're running a multicolor job, which I'm sure most of you do every day, you've got registration tolerances that you have to live within. Okay, so as an example, these color blocks in the middle of the screen here, this blue and yellow and green, they will move around. They're printed on different print units, and there's a tolerance, and it's okay for them to move a little bit. Okay, but because those tolerances, maybe it's 0.1 of a millimeter, 0.2 of a millimeter, while it's quite small for color areas, within the text areas that these can be very, very small characters, 0.1 and 0.2 of a millimeter tolerance can really impact the performance of an inspection system in these high frequency areas. So in this case, it can be the text, but it can be in the QR code or a barcode, where because it's so dense, you've got so many tiny little features, if you apply a color-to-color register tolerance inside an area that's made up of just a single color, you can essentially mask out that area and make it impossible to detect defects. And that's, again, just one example of the power of the PQV product for labels, is that it can track every individual character individually, and therefore it's able to detect a missing character, a missing dot over an I, a broken character, or incorrect characters better than any system that's out on the market. All right, just one example of the capability of the product. But to get back then to the application side of things, so again, the PQV can be, whoops, sorry, I skipped on. It can be on a web press, on a sheet press. It can be on rewinders or slitters. It can be on sheet transports. Anywhere within your workflow or any type of application, the product will fit. And that's important, right? Because I think workflows today have become more complex. There are more steps involved in these label printing workflows today. So the ability to have a product that can fit in many different areas is an important thing to have, all right? So then I'm going to switch over now to data. So what we've talked about so far is an inspection system that is generating high quality data. It's telling me I've got a defect, it's a color defect, or it's a text defect, and it's in a given location on a specific label. And now I want to use that high quality data to manage the waste that's in the process. All right. So the PQV platform has 3 different steps or 3 different products. All right. And I'm trying to use a very simple kind of a workflow representation here. So we're just going to focus on the bottom section for a second. So on the bottom left-hand corner, we've got a printing press, and we have a PQV on that press. Okay. And above that, we have the PQV user interface, which we've seen. And what it's doing is it's showing you images of each defect that's detected on the main image screen. And then it also shows you a map of all of the labels that have been inspected and all of the defective labels that were detected. So you can see, a high level view of the quality of the roll as it's being created. And you can look at any individual defect image and see what the issue is. All right. So that inspection system is generating maps. Okay. So this is an example of a map. Okay. So this may be one production roll of material, and it has a number of defects scattered through the map. Okay. Through the roll. That data gets stored in a database, which we call our edit workstation. And that edit workstation is another device where you can review the information after the rolls have been created. So this first system is on the printing press or on a rewinder. This second system can be located in many different locations. It can be in the quality department, the production manager's department, wherever the data is needed, where somebody was going to make a quality decision. All right. So at this step, the operator can click on any one of these red labels and again, look at the defect on the screen and make a quality decision. Okay. Do I want to accept the defect, or do I want to leave it red because it's something that must be replaced? All right. Once you make those decisions, the map has now been updated, and you have areas of the map that are now remaining red because we want to remove them. And maybe some of the defects we determined were acceptable because they were a low issue type of defect. All right. So now that map with the edits in it is communicated to the final step in the process, which is our control workstation, which again is another software product that is physically connected into your rewinder or slitter or sheet feeder. And what it can do is it can start and stop that machine where the defects are so that the labels can be either cut out or replaced. And again, there's a lot of flexibility around what we do in the finishing. So we can support just removing material. We can support replacing a defective label with a good label. We can even support rewinding that new label back and then inspecting it a second time to ensure the new label is also good. All right. And the idea is that we're using a software platform that has a very strong common look. You'll see that these three user interfaces are almost identical. So somebody who can use the inspection system can also review and edit roll maps, or can run the control workstation in finishing. So the cross-training aspect is very easy as well. Really the only difference between the two, editing and the control workstation, is they have a slightly limited set of options available, because you're now just editing and reviewing the information rather than getting the information into the system. And all of that combines using all of the data that's been generated by the inspection system and then communicated through the database into the finishing department to allow you to potentially run very commercially acceptable product. All right. The idea is that you have the data, information to essentially remove all the defects in your workflow if you desire, but also it allows you to make trade-off decisions, business decisions, to say that, okay, customer X does require 0 defects. They're our premium customer. They demand perfection. You can deliver perfection. If it is a different customer that have, a reasonable expectation that some defects or variation will be in their product, you can make a different decision where a certain amount of that material will be shipped to that customer because they are happy to live with that issue, and it also allows you to preserve margin. And again, ultimately what we're trying to do is drive to the bottom line, right? We're trying to keep your customers happy. We're trying to provide you tools to win new business. And we're also trying to make sure that you are internally as efficient as possible so that every rupee that's spent or placed in an order, as much of that as possible is transferred into your profitability as a business. Okay. Then I'm going to just get in a little bit around telemetry. So telemetry, again, it's data, but it can also be converted into information. And I'll try to explain the difference between data and information here. But what are we trying to address? So some of these pain points are, so a printer might say, I don't know what's going on in my press room. In other words, I don't know if the inspection system is being used, if it's turned off, how many defects are happening per hour, or maybe my staff needs to react to different types of information. So somebody needs to know if a certain thing is happening. And this is where we start to turn data into information. So the PQV can generate the data. It says, I am detecting 50 defects every 100 meters of material. The information is where we have this other platform called AMP, which I'll go into in a little bit here, uses rules to analyze the data and convert it into information. So you can set up a rule that says, okay, if I'm getting more than 10 defects per 100 linear meters of material, please notify me. This is too high. This is too much waste being generated. I need to know as a production manager or a quality manager that something very significant is occurring now on the press and I need to take action. Okay. And this is where the AMP platform comes in. And again, I'll speak to that a little bit later. But we also have another tool called real-time monitoring. So both of these tools, AMP and real-time monitoring, provide you essentially real-time running data. So you can look at a screen and it can show you information from multiple inspection systems running in real time. It can tell you what presses are running, what jobs are being printed, what roll number you're on, even what operator is logged into that specific PQV and is using it currently. And then it can give you production information like when is it the estimated time to completion? And it can figure that out because it knows the run length, it knows how much linear meters of material need to be produced. It knows how many linear meters have already been printed, and it knows the defect rate. So it knows that 5% of what has been printed so far has been detected as waste. And using those pieces of information, it can give you an estimated time to completion. So again, we're turning data into useful information, things that you can use to take action. It can be to address a quality issue. It can be to understand when the next job goes on the press from a scheduling point of view. But again, it's all about making you an informed business, making you a more efficient business. Okay, so we'll now get into a bit more about the AMP platform. This is probably the biggest kind of technology advancement that I really want to talk about today. So up until now, we've talked about inspection. We've talked about advanced algorithms to provide high quality data. So there are inspection systems on the market, 100% inspection. There are defect tracking solutions available to allow you to find the waste in finishing. But we do things maybe a little bit better than most. We certainly add more information around that situation. But now I'm going to talk about a new platform, something that's kind of an enhancement that goes beyond just inspection and just defect information. So AMP is many things. Okay, we call it Advanced Measurement Platform. We say that what does it do? It allows you to maximize performance, AMP. Okay, so it basically is leveraging the concept of IoT, right? The Internet of Things. It's a software platform, cloud-based, that can connect into many different edge devices. So for today, I'm talking about AMP connecting into the PQV inspection system. So the inspection system is an edge device, but the AMP can actually connect into anything. It doesn't have to be a Baldwin piece of equipment at all. It can connect into your printing press. It could connect into your drying system. It is, independent of Baldwin platform. It can be connected into anything. And the idea is that we want to use AMP to do more than just help manage defects. We want it to help you manage your entire business. So, being able to connect into your printing press can allow us to pull data again from the press to say, is the press running? What speed is it running at? How is that press comparing to its peers? So the other presses in the same site, or maybe presses in a second site. Is site A performing better than B? Does it have higher average run speeds? Does it have higher average uptime? It starts giving you data to really build a picture about your business. But also you can drill right into the weeds and you can go look at a given role, look at all the defects in that role and understand how well has that role been printed and compare that role to your typical role, right? So you can start to build standards for your business. You expect that any given role will not have more than 3% waste. Does this current role meet that? Is it more or less? Why does one press perform better than another? Okay, so again, it's about valuable data gathering. It's about driving to print 4.0 or industry 4.0. Again, just about this data connectedness. All right, so it ultimately allows you to advance your business. Okay, so the live telemetry I've talked about, you get real-time feedback of anything that you need, right? And on any platform. So because it's cloud-based, you can look at this information on your laptop or your desktop. You can look at it on the go on your mobile phone or on your tablet. Okay, you've got access to this data anywhere you like. I talked a little bit about the rule engine. So again, this product allows you to use standard rules. It allows you to create your own customized rules. So again, as I mentioned earlier, you might want to set up a rule that says, if I get more than 200 defects in a role, I want to know about it. I want an email. I want as a CEO to know there's something happening on a given press right now that is unacceptable. I want to call the production manager and ask them why. Okay, so you can have a lot of rules, a lot of intelligent analysis of the data to turn it into information to help you drive your business going forward. Okay, so just again to talk a little bit more about the AMP. So how is that assisting you then as a business? So it assists you in a lot of different ways. So we use 3 examples here. So we talk about the CEO, the production manager, and even the press operator. Okay, so what does it do for the CEO? So the example here is, okay, it'll give you a live look at your entire operation, right? So you can have a customized dashboard that allows you to see how a group of presses on site A are performing versus the same type of presses performing in site B. It allows you to understand what uptime you're achieving in a given facility. What is your standout press? Why is that press performing better than the exact same press in the same building right next door? So it starts to allow you to see how your business is performing and identify weaknesses or areas of opportunity or improvement as a business owner. As a production manager, you can use a slightly different set of data points and rules to allow you to look at what are the things that I am in control of, or I manage, and how can that data help me improve the tools and machines under my control to provide better efficiency, better performance. So again, a production manager can look across multiple presses. And as I said earlier, it doesn't have to be how is inspection system A comparing to inspection system B. The AMP product can connect into your press, can connect into other third-party devices. So you can get a much bigger picture of what's going on. So again, it can be about, press uptime, press speeds, dryer temperature, is there something wrong with some piece of equipment on the press that allows you to start to become more preventative around maybe maintenance of different pieces of equipment. And then finally, for the press operator, it can be very simple rules, like if your operator is expected to look at the roll map and look at each defect and make a quality decision, you can set up a rule to say, are they doing that? Are you seeing the operator make those decisions as those defects come in? Because if they're not, again, you can be notified as a production manager that the operator isn't maybe doing their job correctly, or at least in the way you expect them to use the piece of equipment that they're currently using. So again, this whole AMP platform, it's extremely significant for us. It's really one of these really newest things that are coming out, and really trying to, again, leverage the IoT world, try to address the needs of this Print 4.0, and really trying to become more than just something that is a Baldwin product, but something that is truly a product that can be applied to all aspects of your business as a printer. Okay. So then, after all of that talk, I kind of want to get into the revenue and the bottom line. So this is, again, just a little bit of a recap then of the different areas that we've discussed today. All right. So we've talked about the PQV. So again, this is the 100% inspection system. So again, there's two levels for today. One is inspection data and managing defects, and the other then is more of the IoT world and Print 4.0 and online instant access in real time to valuable information to drive your business. But for the PQV, what does an advanced inspection system offer you? So it offers you immediate feedback that you have a problem on press, so you can take immediate corrective action. So that can increase your efficiency, because you are fixing a problem when it happens, rather than leaving that problem continue for much longer, generating more waste, requiring you to run longer, or maybe even come back to press to complete the job because you didn't run enough in the first instance because you didn't realize there was more waste being created than you expected. All right. So it also allows you to know when you can stop printing a job, because you have a target linear meterage of material you need to print. The PQV has told you that if you needed to print 100,000 meters or 100,000 labels of material, and you had 5,000 defective labels, you knew you ran to 105,000. So you stopped when you had achieved the minimum amount of labels required for the job. So you're on press for the minimum amount of time, and you're not returning to press to reprint extra labels. Okay, you get process improvement as well. So with the inspection system and the data that it's generating, you can start to identify underlying issues. Okay, so maybe you run the same product on multiple presses, and you see that one press performs extremely well and another performs not so well. Why do they perform differently? And you can use the data to analyze the problem. So it just allows you the opportunity to go investigate and try to ensure that all of those presses perform in a similar way. Okay, and then all of that ultimately drives to quality improvement, right? So we are minimizing the amount of defects that are getting into your workflow because we're giving you real-time alerts, but then we're also allowing you to remove the defects in your workflow. And again, the idea here is we're probably not trying to remove all the defects. What we're trying to do is remove an acceptable amount of material that allows you to keep your waste level at a point that allows you to generate the margins you need as a business. Okay. And then the second part of that workflow was the editing and control workstations. So again, now we're talking more about business decisions. As I said there, you have all the data and you now want to decide what's the worst material in this job. That's the material I need to take out. I'm trying to balance my risk against achieving acceptable margin. So that means I'm probably going to ship some wasted product to a customer, but what I want to do is make sure it's the least offensive waste. I want to make sure that our defects that are probably maybe just outside of tolerance and something the customer can live with if they find them. But I also want to take out the defects that are definitely not going to be acceptable and would cause the material to be returned to you for a reprint. Okay, so that's the balancing act. But also, I mentioned you can remove all the defects, and that's if that is the requirement for your customer, 0 defects. Again, with all of that data, that information, you can achieve absolute 0 defects and absolute perfect print going to your customer. All right. The increased efficiency on the edit workstation comes from the automated stopping for the defects. Because the control workstation is physically connected to the rewinder, it will tell the rewinder to slow down and stop and put the defective label at the splice table. So there's no looking for the defect anymore. There's no running the machine very slowly, trying to find a defect. You can run the machine at full speed up until the point the defect is coming, and then the control workstation will give a signal to the rewinder in advance to slow down and stop and put the defect in the right location. So the operator can quickly remove the label, replace it with a good label, and then carry on. All right. And all that drives then to customer retention, or reduced returns at least, right? So what we want to do is make sure we meet our brand owners' expectations, our customers' needs. If our customers or your customers are going to be happy with the level of quality you can deliver with these pieces of equipment, they are going to keep coming back to you for business, right? You are going to be able to use this workflow to go out and win new business, because you're going to have a competitive advantage. You will be able to take this to another brand owner and say, this is what we're achieving for brand owner X. They're a very happy brand owner. We can do the same for you because we have the capability, and you can achieve more business. And then the last bullet.
We are running short of time.
Yeah, I'm almost there. It's one slide to go, nearly there. And then for AMP and real-time monitoring, again, it's all about data connectedness, as we talked about. Live business information. You need to have information at the right levels, the right information to make quality decisions at every step in the process. All right. And then finally, we go back to that original slide, and what have we achieved with all of this? So what we've achieved is increased revenue and enhanced bottom line, because we're eliminating customer returns and we're keeping our customers. We're getting quality improvements. We're getting efficiency improvements. And we have business information to make the best decisions for our business to continue to grow the business going forward. Okay. And that is it.
Thank you. Thank you very much, John, for a lovely presentation. I would like to run a poll before we start the question answer session. So I'm launching a poll. I would request all the participants to please answer the poll. Okay, I've launched the poll. I request all of you to please answer the poll. I would request all the participants to please give their opinions on the question answers which have been placed over here. another minute to go. I request all of you to please answer the poll. Anybody else who's answering the poll? I assume everybody has.
I believe this is only for the guests to
Yeah.
poll.
Yes. So I end the poll. Thank you very much for your response to the poll. Now I would request you to please unmute yourself and ask any questions you may have for John on the data management advances which he's talked about, which would help you improve your efficiencies. So if there are any questions, I would request you please raise your hand so that I can unmute you and request you to answer them.
So there is one query posted there in the chat box by Mr. Muhammad Ali Tarmiz.
Yeah.
So Mr. Ali, if you can please.
Yeah, I'll just read that question out. Is it possible to integrate the Baldwin system in the ESCO automation engine workflow? John,
So, yeah, so there's maybe just two answers to that question. I think the first answer is yes. Okay, so we don't have a deep integration into the ESCO workflow. What we have is the ability to accept the PDF outputs that ESCO can create. So as long as there is a PDF artwork file in the workflow for any given job, we can use that PDF artwork file to do that automated job setup that I talked about earlier. So there's information in the ESCO workflow that allows us to essentially preset the PQV for inspection so that it can be very quickly switched on once a job runs.
Okay. Any more questions? I don't see any questions coming up.
I must have been given a very good explanation, I guess.
Looks like. Okay, there's another question in the chat. I need to print number of defects found and type of defects found in one job.
Mm-hmm.
Can I do that?
Yeah. So the PQV platform has a reporting system that allows you to create job reports and role reports, and within those reports, you can list all of the defect types and the numbers of defects that occurred, and you can even include the images of each of the defects in the report as well.
Okay. There's another question by Mr. Push Desai. Mr. John, since IoT is aggressively improvising and changing our working styles, how precisely can it help us in bettering our quality in our industry?
Yeah, I think IoT is going to be a massive part of the future of how we have quality and efficiency in the businesses. And that's why I wanted to spend a good bit of this call talking about this AMP platform that we have launched, because I do think that is kind of the next generation of quality tools, because what it will ultimately allow us to do is get information from everywhere, right? I mean, the Internet of Things, right? So it's everything out there. As new technology advances, are IoT equipped, right? So they can provide information in a format that can be read in by a product like AMP, and then AMP can basically consolidate all of that data and then apply rules or logic to it to be prescriptive, right? So I talked about having data, having high value data, and then having information, and that's where the IoT and the AMP type product is going. It's taking the data from everywhere, right? So it's not just inspection system, it's not just a printing press, it's not just a dryer, it's whatever. It's all of these things combined, and using the data and analyzing the data aggregation, you can figure out what's wrong. You can say, okay, I'm getting a lot of print defects, and it turns out that really the dryer is underperforming. It's maybe not hot enough, and you're getting a lot of ink that's not curing, or it's not dry, and it's causing lots of defects. So by having multiple inputs, you can start to build a picture of what is happening, and you can actually become informed. So you just don't have waste. You have a dryer that needs preventive maintenance, or not preventive maintenance, it needs to be fixed. It's causing issues for you. So that's where the IoT world is really going to take off, because it will just come up with the answer for you. You will just be told, you need to go fix this piece of equipment, and this is why, because I've analyzed the data and here is your problem. So it's going to become extremely important in the future.
Okay, thanks. There's another question by Rajesh Himaji. He's asking, in 10 years from now, where do you see the inspection systems? They're sort of advancing at a similar pace, right? So yeah, if you kind of go back 10 years in the past, it was a very different thing. I think what will happen with inspection systems is they will just continue to become more intelligent. So what we see is that hardware processing is getting faster and faster, software is getting faster and faster. So you can do more things in the same amount of time it takes to print a label, right? So label printing isn't necessarily increasing in speed nearly as fast as the processing power is, okay? So that means you can, rather than look for 5 different types of defects on a label, in the future, you will be able to look for 50. So it will just enhance the quality again of the data. So the inspection systems 10 years from now will be clever enough to ignore things that are truly not of any concern to you, rather than generating false detections, which is a common problem today. And I mentioned earlier, often the inspection systems are set up too sensitive, and they create thousands of defect events, and the user, can't really see the defects they can fix. They just see a lot of noise. So they'll get much better at reporting only things that are of a concern, and it will get much better at telling you exactly what the issue is, so that you can take exactly the right steps to fix the problem. So I think that'll be the difference. Intelligence driving the right actions. So, improvements in efficiency will come from it as well. There's another question from Ahmed Mustafa. He's asking, can you use the system in Kodak workflow?
I didn't catch the end of it. Which workflow? Kodak. Again, from a digital point of view, it's really very similar capability that we would have with an ESCO workflow. Really, the capability is around using the PDFs for setup. That said, while we haven't any integration currently with Kodak, it is certainly something we would be interested in talking to anybody about, because as we develop the AMP platform, that is going to be the platform that will do all of the communicating for us. So, Baldwin is focused on having AMP be the tool to connect to the world. So we would be very interested to have a discussion about that, because our plan would be to be able to have the AMP platform talk to Kodak, and then pull in the information we need to automatically set up, not just an inspection system, but maybe it's an inline spectrophotometer that we have, or a web viewer that we have. So there's definitely potential, but right now we don't have a very strong connection to Kodak. We're very interested to have a conversation about it.
Okay. We have another question from Rajesh Himaji. With digital printing taking big leaps, so you foresee any utility of inspection system, as in digital there will be no print defects, hopefully?
I'm sorry, I can't quite hear the question.
I said, with digital printing taking big leaps, so you foresee any utility of inspection systems, as in digital there will be no defects or very little defects?
Right. Yeah, that's the hope. Reality is still a little different, I think. But again, the PQV actually is probably one of the systems on the market today that is very well optimized for digital print inspection. So it has capabilities around variable content inspection already. So, again, if you're running variable codes or variable content, the system can accept data files and then compare the printed product against those data files. So the variable nature of digital print is reasonably well covered by the PQV already. If it's fixed data, then it's no different. We have experience on digital printing presses. There's a lot of people coming out with digital solutions, with hybrid solutions, with digital elements, and there are still plenty of defects to be detected with digital print. One other functionality that we offer as well in the PQV is the ability to do jet out or nozzle health inspection as well. So we've created a couple of custom interfaces where we can check just the the quality of the jets periodically. So it's not something that runs in production, but something that is used sort of as a setup or a test utility. So at the beginning maybe of every job or every shift, we can check that the digital printer is printing correctly, independent of whatever print job it needs to print. So we have functionalities, we have capabilities that I think are very complementary for digital applications.
Okay, there's a question from Push Desai. Can you brief a bit on Print 4.0? How can it revolutionize the industry?
I didn't hear the end of the question, the last piece.
How can it revolutionize the industry?
Okay, yeah. So I think it's similar to the answer I gave on IoT. It's just about It's just about having data, having a lot of things connected, allows you to turn data into information and ultimately into the right decision. So it can help. Really, it helps being proactive. Right now, I think we're still in a reactive world where we have tools that allow us to see a problem. The problem is there. Then we go and we fix it. What the Print 4.0 or Industry 4.0 and IoT, all of those things combined in the future are starting to give us is the ability to predict things, get more proactive. So again, I use example of a dryer that's not running at the right temperature. It might be working okay right now. It might be running at 90% efficiency, but again, with certain rules applied and having connection to that device and monitoring it 24/7, you can start to build up a picture of how that's degrading. And with larger populations of the same devices and more data about how well they work at certain temperatures, you can start to put real intelligence into these platforms, and you can start to say, okay, just letting you know, Mr. Printer, this particular device is running at 90% efficiency. It's still working, but if it drops below 87% efficiency, you're going to start to see print defects. Now is a good time to schedule some preventive maintenance. That's the type of scenario I would expect to see in the future once we start to really see that industry or Print 4.0 take off.
Okay, thank you. Now I would request Mr. Raj Rana to propose a vote of thanks, as we've also run out of questions. And just a small thing before Raj Rana takes off, there's a question by Mr. Hassan Ayub. What is the meaning of LMAI? LMAI is Label Manufacturing Association of India. Here we are a set of printers who are converting roll-to-roll labels, and we are all got together and we run an association which helps feel each other's problems, or we grow together and understand each other's requirements together. So that is the purpose of LMAI. Thank you. And I would request Raj Rana to please propose a vote of thanks.
Yeah, thank you so much, sir. And my name is Raj Rana. Just to introduce, from Baldwin's Vision System. I'm based as I'm a sales manager, Baldwin sales manager in India. It is my honor and privilege to give vote of thanks to all those who make this assembly and webinar a success. This is in spite of a difficult COVID pandemic. Availability of time is very less, but it turned out to be okay and it came very well and gone very well. Thank you so much. We would not be here without LMAI. Thank you so much, LMAI, creating such a nice and fantastic platform and to discuss online few of the important aspects of our labor industry. We have very special regards for LMAI as LMAI is different. For the webinar, we closely worked with Mr. Manish Panchal and Jaideep sir. Thank you, sir. Thank you so much, both of you, for your kind help and assistance. Also, as many thanks to Mr. Rajesh Nima. He originated everything, and whenever we went to him for any clarification, he was coming forward and helping us. Thank you so much. For the all audience, many thanks for your joining and from your busy schedules. And I know this is very, very difficult for everyone to spare time at this point of time. Thank you so much.
Thank you, Ranaji. Thank you, John. Thank you, Jaideepji, Anuragji, and thank you all attendees.
Thank you, everybody, for being here with us. And look forward to seeing you in our next webinar.
Yeah.
Thank you very much.
Okay.
Thank you, John.
Thank you. Bye-bye.
Thank you, everybody.
Thank you.